It's been a very stimulating day, and this is our last panel on AI literacy. And our first speaker is Shuchi Grover, and she's a learning scientist and computer scientist working at the intersection of CS/STEM/AI plus learning education for over 2 decades. She is currently director of AI and education. Oh, sorry. She's currently director of AI and education research at Looking Glass Ventures. Shuchi led 3 NSF-funded AI education projects in the past 5 years, 2 on AI learning in high school, and 1 Gen AI in high school mathematics classroom. She advises teachai.org, a generational AI project in Finland, and is part of the Artificial Intelligence Research and Education Alliance. Welcome.
Thank you very much, Uri, Nell, all the organizers of this fabulous symposium. Just starting my... I'm delighted to be here. So we're going to finally, at the very end of this day, talk about AI literacy. Most of the conversations this morning have been about AI in education. This is about AI education. So I hope you sort of see the distinction. It's teaching about AI as opposed to teaching with AI. Before I start, I want to draw your attention to this ridiculous image that was generated by Dali, the very first image that came out when I prompted that prompt. And it sort of, captures the zeitgeist, not the mood in this room, but, an oversized AI sitting at the same table with humans that are totally being dwarfed by it. I did not do anything. That was exactly the first image that emerged when I gave it to Dali. So AI literacy has become the buzzword since 2023, not just in the context of learners and students and schools, but also higher education and for parents. That headline sort of is pretty scary. Jaemarie AI chatbot is now going to be available to kids under 13. So what should parents know? Board members, HR, policymakers, everybody is talking about AI literacy. And in a world of very wild headlines, this one probably takes the cake from a couple days ago. I think it all started with this warning that the World Economic Forum sort of launched across the world in 2022, saying that without universal AI literacy, AI will fail us. I'm not going to delve too deeply into that, although we could have a long conversation about that. But are we all on the same page about AI literacy? Do we even all define it in the same way? So let's look at a few definitions, starting with this wonderful one by Long and McGurko, Duri Long and Brian McGurko in 2020, well before ChatGPT came out with this wonderful paper. I suggest everybody read it. It's about a set of competencies that enables individuals to critically evaluate AI technologies and effectively communicate and collaborate with AI, use AI as a tool online at home and in the workplace. And since then, several new definitions have emerged from various entities, including the EU AI Act, Digital Promise, EDUCAUSE, the California AB 2876 bill, which also defines AI literacy. And most of them sort of cover similar things. It's 4 things, really. What is AI and how it works? How to use AI tools, how to critically evaluate AI, and then issues of ethics and benefits and risks and safety, etc. If you Google AI literacy, you'll see several interesting images as well that sort of probe a little bit deeper. For example, the Digital Promise picture sort of has these underpinnings of data literacy and digital literacy and computational thinking elements, etc. Long and McGurko sort of have these 17 sub-competencies under what is AI, what can AI do, how does AI work, and also design principles, very exhaustive. And how does AI work kind of gets pretty technical, as you can see. I don't know if you can read those. EDUCAUSE sort of splits it into 4 dimensions: technical, practical, evaluative, ethical. And UNESCO has come out with AI competency frameworks, both for students and teachers. And they sort of follow this progression of understand, apply, to create along 4 dimensions: a human-centered mindset, ethics of AI, AI technologies and applications, systems design. And for teachers, they sort of have one pedagogy dimension as well. And not to be left out, PISA, OECD, and EU have just announced a media and AI literacy assessment, MAIL, to be launched in 2029. And it's going to sort of, they need to understand how digital and AI tools are being used by students and how they understand consequences, et cetera, et cetera. And they have a lot of buzz around announcing the AI literacy framework. I think the AI literacy framework to rule them all, maybe, because there's an exam associated with it, right? So there have been some, tricklings of glimpses of what it's going to cover, interacting with AI, creating with AI, managing AI's actions, and designing AI solutions. And they have these adjectives that sort of design principles: interdisciplinary, foundational, practical, illustrative, durable, global. They have partnered with code.org, Teach AI, to do this. And if you're like me, you're wondering, why the rush to announce a test on knowledge of tools that are still evolving, that are still emerging, and that didn't really exist until yesterday? And I think it's all about something that has been captured in today's conversations. There's a lot of sort of market forces pushing us to sort of internalize this idea that AI won't replace humans, but humans with AI will replace humans without AI. Okay. So, so defining a literacy is not very straightforward. Think about scientific literacy, mathematical literacy, computational. These have been evolving and changing and sort of developing over time and or with time. And if you think defining is difficult, operationalizing it is even more difficult and challenging. Take, for instance, this phrase that you see in a lot of the definitions: understand how Gen AI works. What exactly does it mean? I can throw up several questions. Is it about being able to get Gen AI to generate text, or is it about explaining how it did it? How deep should that understanding go? Is it about knowing the difference between a reasoning LLM versus a search-based LLM, which is what the buzz is these days? Is it about knowing fine-tuning, or knowing terms like RAG and reinforcement learning with human feedback, temperature, context window? The difference between generative AI versus predictive AI, understanding how the machine has learned from data, understanding bias in, bias out, knowing why hallucinations happen. I mean, even companies don't know that, right? We've just read that news article about OpenAI not really understanding why O3 doesn't hallucinate more than O1 or whatever. Describe how LLMs work. Describe the transformer architecture. We don't know. Are we talking about learning machine learning, how neural networks work? Or is it about those foundational skills, data, computational thinking, or something else? Is it some combination of these or some of these? So, operationalizing these phrases, understanding how Gen AI works, it's easier said than done. And that's because literacy can be seen as what we might think of as a boundary object. It's for everybody. The idea of literacy means everybody should have it. But it means different things to different people, even in the context of AI literacy. For students, for teachers, for someone in industry, it means different things. It's context dependent. It involves concepts and practices, and sometimes those cause tensions. So knowledge elements, practice elements, distinct elements, but overlaps with other domains. We saw this with computational thinking. It overlaps with mathematical literacy and design thinking, design literacy. It has fuzzy boundaries, and measurement is difficult. So with that very upbeat introduction, I'll go into talking about a few things that I was given as a charge, sort of a landscape of where AI literacy is. These 3 elements will sort of be intertwined in the first part of the talk, and then I'll talk a little bit about gaps, limitations, next steps, and sort of bring in some of the learning sciences into the conversation. So the answer to the first question, what is the current state? It's really all over the map. There are a few key players in the space: schools, academic and research institutions, nonprofits, new ones cropping up every day, international organizations, and industry. And industry seems to be exerting a fair amount of influence right now on both nonprofits and international organizations. Take, for example, Common Sense's Grab and Go AI literacy lessons for grades K to 12. These are bite-sized lessons on what is AI, how is AI trained, AI chatbots, understanding bias, how it impacts our lives, a little bit on facial recognition, etc., AI and plagiarism. And if you look at the rest of the landing page, you see that there's a lot of conversation about ChatGPT. And it all starts to make sense when you realize that OpenAI has partnered with Common Sense Media to create this AI literacy curriculum. Microsoft similarly has many bite-sized, training modules for educators, and most of them are focused on Gen AI. So you start to wonder, is AI literacy really about Gen AI literacy alone, or is it something bigger? And so it's about using Gen AI tools in the classroom, etc. Microsoft also has a Minecraft-focused AI literacy curriculum that is focused on learners, and this sort of takes off from their CS education work. Maybe Chad knows about this, given all the stuff that he's done with Minecraft over the years. And it sort of talks about the foundations of AI, but all within a learning by doing environment where you're sort of doing things in Minecraft. And it's similar in some sense to a Scratch AI module that I came across that is a 5-hour sort of introduction to what Gen AI is, but it's hands-on with the face sensing, blocks in Scratch, but also pointers to articles and discussion points, etc. Let's see, so that's what it looks like. And though not an AI literacy curriculum, we have guidance from the KPOR Foundation on the responsible AI and tech justice. It's a report, a guide for K-12 education that sort of speaks to the ethics pieces of it and the critiquing and critical sort of lens toward Gen AI. Who is creating these technologies? What are their motivations? Who benefits? Who's harmed? Who's prepared to create and decide future innovations? And who will get left behind? So this is what's been happening these last couple of years. But a mere 2 years ago, in a world before ChatGPT, things looked a little different. There were several NSF-funded projects. NSF started funding AI literacy and AI education efforts around 2018, 2019. This was a report that was produced in 2022 that sort of presented all the projects and what sorts of things we are looking at. I was one of the projects that had been funded. And in fact, I wrote a synthesis paper last year, which also won Best Paper at the 6Z conference last year, that sort of synthesized all this early research and what we were learning, what the research was focusing on, and what we were learning, and guidance for how CS and AI would move forward. One of the first efforts that was funded and that launched the AI for K12.org organization articulated what students need to be learning in the Big Five Ideas framework. And it included perception, students perceive the world through sensors, representation and reasoning, agents maintain representations of the world and use them for reasoning, computers can learn from data, intelligent agents require many kinds of knowledge to interact naturally with humans, and AI can impact humans and society in positive and negative ways. So a lot of those efforts during those years sort of took this Big Five Ideas framework. The MIT RAISE initiative had several projects that sort of looked at this and built curriculum modules for middle school especially. There was the daily curriculum, the ethics-focused curriculum, and the daily curriculum, for example. Now you start seeing a distinction. I don't know if you can read that, but maybe this is more readable. But they had initially 4 units and now 5, which the 5th one is the LLMs one, which had students looking at supervised machine learning, understanding neural networks, generative adversarial networks, thinking about, of course, the impact of AI on society, etc. But it was very much around, sort of understanding these machine learning techniques and whatnot, all in very sort of engaging ways. I mean, that was what the research was funding, what are good pedagogies to get these ideas across to students. The AI for Georgia initiative was similar. This was led by the people that had created the AI for K-12 Big Five Ideas, Dave Turetsky, Christina Gardner-Bacune. They had these modules on, computer vision and sensing, natural language processing that sort of talked about K-means clustering, n-grams, all those techniques. Before LLMs, people were talking a lot more broadly about AI techniques until, Gen AI sort of snatched all of that away. And across the pond, Experience AI, the Raspberry Pi Foundation partnered with Google DeepMind to come up with a curriculum that, again, sort of talked about how computers learn from data, bias in, bias out, decision trees, model cards, et cetera, et cetera. The Generation AI project in Finland took a slightly different tack. They actually looked at, how students need to sort of be taught to, survive in a very rapidly changing world with data. And so it sort of combined the digital literacy piece with lifting the hood on how machine learning works. But it also sort of went into elements of ethics and the digital footprint students leave. They have some very cool activities that they designed for students to sort of play around with those activities, but also understand, go deep into some of these conversations. I myself was involved in 2 NSF-funded R&D efforts to design AI learning for high school students. The first one was CS Frontiers, a 4-year effort where we designed a modular curriculum for high school students that had sort of completed all the introductory stuff or even APCS principles and sort of engage in some of these exciting topics like distributed computing and AI, ML, cybersecurity, and the Internet of Things, very interdisciplinary, very data-centric. And the other was an exploratory efforts of how we might bring cybersecurity and AI together and actually have students grapple with issues of cybersecurity through the lens of AI, or look at AI techniques through the lens of cybersecurity issues. And the idea was maybe lift the hood a little bit on how these models work, because we felt that issues of ethics and bias, et cetera, that we talk about are not always so apparent when you don't know what's happening under the hood. Both of them relied on a block-based programming environment called NetsBlocks, which is an extension of the Snap environment with amazing capabilities to access APIs and web data sets, et cetera. And this is what the curriculum looked like. We actually started with the old AI search algorithms and then went into machine learning, natural language processing, music sentiment analysis, et cetera. And the AI for cybersecurity, AI and cybersecurity curriculum sort of looked at cybersecurity issues, cyberbullying, bot detection, all that. And we introduced AI ML with freely available tools like Google Quick Draw, which sort of has some very amazing activities students can do to understand how a machine learns from thousands upon thousands of data points and images. But we took it further because we want the ethics conversations. We went to the GitHub pages to see what data had been captured by Google when people were playing with this around the world. It was really training their models. But this was the data being captured, and then a discussion on, is it harmful? Should you have been told? This feels fairly harmless, but in some other circumstance, should you be told when, even CAPTCHA, I don't think people understand that they're training models when they're clicking on those images, recognize the traffic signals or things like that. We had a sentimental writer activity which used an API called Parallel Dots, which classifies text into positive, negative, or neutral sentiment. It can also classify sarcasm, hate speech, all those things. So we had, so students in their final projects were sort of classifying the sentiment of, or bias, looking for bias in New York Times articles, or the sentiment in Taylor Swift lyrics and things like that. We had a Twitter bot detection activity where, students created a rule-based classifier, but before they did that, they sort of examined the data. They examined data features to see how they might sort of, what are the features that might point toward something being a bot or a not bot. And kind of dug deeper, talk about, high ceiling, low threshold, high ceiling. We actually had classifiers built, decision tree classifiers built within Snap that students could sort of play with and actually build a decision tree at the end. And this was very interesting because this gave students a sense for how the machine broke up the decision at points that they might never have done as a human, number of tweets greater than 31, who would sort of think about that. And it also sort of promoted adversarial thinking in the context of cybersecurity. This became a tool for them to sort of think about how, if a model, if somebody knew what the model was, they could create a bot to actually fool the classifier. So, that kind of thinking. So we had a Find the Minimum game, which was a game to sort of build intuition around the idea of gradient descent. So this is in the vein of unplugged activities, Duri's projects, where students are sort of grappling, building intuitions of complex machine learning topics, but in very accessible ways. And this also sort of leads to discussions of that sort of dig deeper into just what the game sort of guides them on. This kind of reminds me of Dan Myers, pointing towards where the coordinate might be. But this was kind of similar, the opposite of hill climbing, if you know. So there are a lot of tools that are freely available that all these curricula have pretty much drawn on. Some of them have been created by sort of the makers of AI itself, Google and Microsoft. There's the Teachable Machine, Quick Draw, TensorFlow Playground, Adversarial JS, Machine Learning for Kids. There is a face tracking tool. There's a PoseNet tool. There's ML5.js. So lots of tools for students to actually sort of start playing around to see how the machine has learned, how optimization happens, and computer vision, etc. But all these projects have also worked very hard to sort of develop these unplugged activities, such as the game that I described. There's also the contour to classification game from the daily curriculum. The daily curriculum also has a game for, discriminator versus generator, GAN, while studying GANs, and there's an algorithmic auditing game that has recently come out. So there's a plurality of pedagogies for building these kind of understandings in students. There's explorations with pre-designed models, digital non-programming interactives, constructionist sense-making, using APIs for classification, unplugged activities, lifting the hood through programming, machine learning models, integrating movement and cultural practices, socially relevant AI applications, co-designing ML applications, and ethics-focused pedagogies. And there's a ton of freely available tools out there. If you really want to sort of bring some of these ideas to the classroom, don't, go to ai4k12.org, the resources section. It's a growing list there. So tracking the shifts, what happened when ChatGPT came? AI literacy, like I said, almost became overnight Gen AI literacy. And while earlier we were sort of had this broader, sort of broad understanding of AI, it sort of started to become narrow, Gen AI-based skills. Conceptual understanding of AI has now almost gone totally in the direction of AI tool use. Some good things have happened over the last couple of years. There's more awareness of issues of ethics because of the way the LLMs have sort of, hallucinated or the kinds of biases that they have shown. And also standalone AI education is now being thought of as something that can be integrated into other subjects because there's wide interest. It's right in the hands of students and teachers. And so people are sort of thinking about AI literacy very differently from the way we did just 2-3 years ago. And the way I look at AI literacy, clearly, there's one general aspect to it or non-technical, which sort of is about the basic understanding of AI. What is AI, types of AI, what can it do? AI, LLM literacy perhaps. And also, not included, but I love historical perspectives. I loved Cheyenne's talk for that reason. Students should have a sense for a history. AI has been around since the 60s. What has changed? What has happened in the intervening years? Ethics and human AI relationship should include understanding a role of humans. How should AI be used? How can we augment or amplify human intelligence while preserving human skills and dignity? And I think critiquing and questioning and perhaps, using the word that has come up several times today, resisting the use of AI should be part of AI literacy. And then there's the technical piece of it, the machine literacy that we might call. How does AI work? What are ML techniques? Because lifting the hood does give you a better sense of what's going on, and perhaps it's something that's more relevant at the secondary grades, not so much at the primary. And then data literacy. It's all dependent on data, so you have to understand the role of data, how data shapes our lives, explore data features, data visualization, and also data agency and data equity. So data literacy, as we all know, is about understanding, collecting, curating, cleaning, analyzing, visualizing, interpreting data. But data agency that came out from the Generation AI project, it basically extends that concept to emphasize people's ability not only to understand data, but actively control. It's like the cookies, question that comes up. What data about yourself do you want collected? What do you want to willingly participate in and what not to? And to sort of be wise and wise about all of that. And data equity, which is this shared responsibility for fair data practices that respect and promote human rights, which is all out the window right now with the way industry is moving with their open AI, with their AI, LLMs, and generative AI initiatives. So these ideas of computing and data are really foundational to AI literacy, and I want to sort of underscore that. We can all agree that these, have to be sort of taught throughout K-12, and so this is the work that we are doing at the National Academies right now toward the tail end of a consensus study, which is defining foundational competencies that can be integrated into all of STEM learning in order to build the foundation for this future of data and computing. Now, when I think about this general versus technical, this dichotomy, I'm sort of reminded of what digital literacy used to be that was pushed, sort of at the turn of the century. Versus our argument for computing education. So digital literacy was mostly about becoming an informed, responsible user of software and the internet, and it was centered on the use of technology. Of course, there were elements of collaboration, communication, critical thinking, and creativity, but it didn't go into the realm of CS education where we lifted the hood on how technology is built. We centered it all on coding and computational creation as a means to access powerful ideas, self-expression, creative expression, and also participation in CS-related careers. And so what does this mean, when we think about AI literacy? And to be sure, both are essential for, preparing students for college careers and civic life. So to me, I'm sort of reminded of the general piece of AI literacy sort of feels very digital literacy-ish. And then there's the technical aspect, which goes into the realm of actually applying, creating AI applications, using APIs. There's a big black box issue with AI, so you can't really create things without sort of maybe using a pre-trained model, or maybe you could, depends on how, tools progress. So in terms of practical integration, we have to sort of integrate AI learning wherever it's appropriate. Perhaps in language arts and art and music, we stick with, sort of use of Gen AI, maybe teach prompt engineering. I wonder about that skill, just given how LLMs are progressing every few months. Evaluate Gen AI inputs. And also, when we're teaching all these things, I think we need to teach them the harms of cognitive offloading, knowing exactly what kinds of tasks to use it for, and the right to refuse use of AI. We've been talking about data agency throughout, the day-to-day. And then in social studies, et cetera, in science, learn about the history of AI, role of humans, the cost of LLM production, labor exploitation, environmental harm. Some of these issues have come up today. Ethics, biases, how different communities are impacted differently. The harms of anthropomorphizing, valuing human skills and dignity, which again leads to maybe I don't want my teacher to become obsolete or something like that, I think students should not just critically evaluate the output of Gen AI, but actively question its use in the classroom or wherever else. Right now, I think, anyway, I won't go there. Um, Dovetailing and integrating computer science, STEM, and AI learning for technical AI literacy. I don't think there is any way you can have a deep understanding of AI without understanding computing. And I don't think CS education today can sort of ignore AI. So the two are really sort of intertwined in that sense. And a great example that sort of defines what this integration might look like is the Gwinnett County Public Schools AI learning framework of the AI Ready Student, which sort of has all these elements of programming, data science, mathematical reasoning, creative problem solving, applied experiences, and issues of ethics and philosophy. So to recap all of this, I think when you think about a foundational AI literacy for all, it sort of has to come from all directions. You have to integrate it everywhere. I don't think anybody is thinking about a standalone AI literacy subject, and so it has to sort of be integrated in with learning of other things, and then maybe an advanced elective in high school where students want to dig deeper into understanding, what AI is. And clearly, there will be some idea of a progression from awareness and use to creation, application, understanding what's under the hood. And this is sort of a rough idea of how it might progress. I don't think this is grade-wise. It's more sort of spiral over the years, whatever makes sense at the various grade levels. All right, so that was sort of a quick review of the state of the field and what the AI landscape is in terms of AI literacy. So let's look at some gaps and next steps. So let's revisit this term literacy, interrogate the word literacy in AI literacy. Do we really want to go where we are headed right now? You've seen the transition from what it was and to what it's become today. It's really become about Gen AI use. Do we really just want savvy users of these shiny new tools? Is prompt engineering really an enduring skill that we need to teach? It's kind of like teaching PowerPoint and Word. I think it can be integrated into the learning process, but I don't think that is the end goal. And even if we do lift the hood on how AI works, what does it do to students' ways of thinking with AI? I think back to the rationale that we had for CS for All. One was to nurture creators, not just consumers, a new representational medium, tool for sense making, develop computational thinking and problem solving skills, broaden and diversify the pipeline of computing innovators. Those were, I think, most would agree, are rationale. I don't know if I missed anything. So, thinking about it in the sense for AI literacy, I think it helps, like many have done today, to sort of go back to these ideas of computational thinking and computational literacy. I don't need to repeat what Papert has said because many have talked about it today. But Andrea De Sessa, who has not come up today so much, talked about computational literacy, not just being about using computers, but which you might call computer literacy or literacy, as you said the other day. But it's about a transformative way of thinking that fundamentally changes how people represent and manipulate ideas. And he sort of, I think, Changing Minds, I had to reread it recently. And funnily enough, it started with, Congress is reducing NSF funding, et cetera. And it was like, oh my God, this happened in 2002 as well. Not 2002, 2000. But he also talked about two-way literacies, not just being, it's both consumption and creation. And this is how he defined it. It's a socially widespread patterned deployment of skills and capabilities in a context of material support to achieve valued intellectual ends. That sounds a little dense. I think it seems more tractable when you think about his three pillars of material intelligence, cognitive, and social all coming together to form a literacy. Material are your external tools, etc., that you use, environments that allow you to use and manipulate. Cognitive are the mental models and capabilities to work. And all of these sort of work in concert in a literacy. And of course, he traces it from reading and writing or math, etc. And some of it Uri referenced this morning. When you think about computational literacy that way, what does that mean for what we are doing with AI literacy? The learning sciences view of technology has always been that these are tools for thought and sense making. mediums for expression and knowledge construction, mediators of social interaction and community building, as Scratch has done so well, as Mitch talked about this morning. And it's not just tools and tool use for productivity or even just creativity, but new tools for knowing and representing ideas. And I think this, we've seen this in flourish in ample measure in the context of computing education, starting with Logo, to Scratch, to environments for, sense making in mathematics, engineering, art, sense making in science and ecosystems with agent-based modeling, with Uri's work in NetLogo, and the systems that followed NetLogo, VIMAP, and et cetera, that are more tractable for younger learners. Virtual worlds like Chris Didi's work, or the work that we have done with NetsBlocks, where we bring in large data sets for students to sort of visualize data, make sense of complex climate phenomena with student-led research questions. We had a project on climate science, data science, and computer science, with students sort of analyzing and coming up with research questions and what could be answered and what couldn't. And we see glimpses of this kind of thing with some tools. Storytelling with machine learning. Tiffany Seng's work around using microbit to develop and train models and have them be used in these little toys that they create that kids can sort of play with. And these ideas of microbit being used in this way have sort of now become a Create AI curriculum, which involves collecting data. Students collect data, they test a model, train a model, there's that cycle, and then they use the model in code. So clearly, it's going beyond just using Gen AI. This is about really using models for doing something with them, or creating models and training models for doing something with them. Going back to Tiffany's work at Apple, co-development of machine learning, collaborative machine learning with families using CoML. In our own work, I talked about the Sentimental Writer project. The students, this is one of the students' final project slides. They actually had a slide on limitations, how the API did not work and where it did not work. So clearly there are ways of actually using these ideas of AI and machine learning to have students grapple with bigger issues, including interrogating the AI API itself. The Experience AI curriculum from Raspberry Pi also has project-based modules which start with a problem of maybe waste classification or data from world's oceans, and then students sort of train a machine learning model. So very much, going deeper with this new medium and this new tool. So I'd like to end with a simple but very key reminder and a few questions. This has come up again since we are all learning scientists here. Learning is at its very core situated and contextual, it's social and cultural, and it's values driven. So given that, these are the kinds of questions that come to mind when we think about how we develop AI literacy and think deeply about that phrase literacy in AI literacy. What role should human values play in AI literacy frameworks? What role should human agency play? I mean, if I'm literate about AI, maybe I don't want to use AI, right? There has to be that option as well. I can resist. How should AI literacy experiences consider cultural context? How can AI learning be constructionist, project-based, collaborative, involve deeper learning while avoiding passive consumption, which is where it's kind of headed right now? How does AI change the nature of knowledge representation? How should the material and cognitive of AI literacy come together to enable new possibilities that help children flourish? How do we balance tool use with conceptual understanding and shift the focus from tool mechanics to epistemological shifts? What new paradigms of learning tools can enable such skills? How can we leverage AI in education to teach about AI? Somebody talked about, we've been talking about bringing in AI into these environments. How about, an element of transparency and making it apparent to the student that this is an AI tool now talking and this is how it's working. And so we can use AI in educational tools to actually teach students about AI. And how do we promote critical reflection on creation processes? How do we leverage ongoing computational literacy efforts, which have been happening for a while through CS Education, for AI literacy? And I will end with, thought I had one more question. I'll end with another Disessa quote, that we have much to gain by thinking carefully about this whole game of literacy and about what we can do with, I've scratched out computers, which is what he had said, and replaced it with AI, that can either hasten or undermine new possibilities. And I have a longer version of much of this talk, but also, talking about AI in education and, how the social sciences can, play a role in this transformative era. And it has just come out in the Issues magazine of National Academies. So with that, I'll end my talk. And I just want to add that some of those questions that I asked in the last slide, I think Duri and Jaemarie have some wonderful projects that sort of speak to some of these things. So I think there's some good synergy there.
Our next speaker is Duri Long, who we're lucky to have on. Still not close enough? I'm just not holding it close enough, sorry. Duri Long is an assistant professor here at Northwestern. We're very lucky to have her on our faculty. And she's in the Communications Studies Department and courtesy appointment in computer science as well. She does work on fostering public AI literacy and studying and designing technologies to support and foster human creativity. She has experience working with artists and museums around the country to develop co-creative embodied exhibits and art installations involving AI and technology.
Thank you so much. I'm very excited to be here. And thank you, Shuchi, for the wonderful overview of sort of the state of the field in AI literacy. I think this talk will maybe complement it well by getting a little bit more granular and talking about specifically some projects that my lab has been working on to design sort of an ecosystem of resources to foster AI literacy in different contexts and for different audiences. A lot of my work recently has been focused on this question of how can we foster public agency and critical decision-making surrounding AI, which I think connects to a lot of the themes that we've talked about throughout the sessions today. And just to contextualize sort of my methodological approach, I take sort of a research through design approach to the work that I do, which means that I engage in a process of ideation, both on my own, but also in collaboration with learners and stakeholders, a process of iterative prototyping and testing through which we build an understanding of what techniques or design principles are effective in conveying concepts, and that work results in a set of artifacts and systems that are an output of the research, but also a set of generative principles that can be used to create or guide projects in similar contexts. So today I'm going to be talking about sort of an ecosystem of AI literacy resources and presenting some of those artifacts and systems that my research group has developed, but also talking about some of those generative principles that we're starting to identify as we're studying these in context and learning about how learners are interacting with these systems and how they're making sense of them. So I'll skim right over this definition because I think Shuchi did a wonderful job of talking about sort of the complex and evolving nature of defining AI literacy. But I do want to point out that a big focus of my work is sort of enabling individuals to kind of engage in this sort of critical decision-making surrounding AI. And I wanted to highlight a paper that I saw just last week at a conference that found that people who they compared people who use AI were heavy users of AI systems versus people who had even a pretty high level technical understanding of how these systems worked, and the people who had even a really high level understanding of how the systems work behind the scenes engaged in a lot more fact-checking behavior when they were interacting with large language models. And so I think this type of finding really motivates the work that I do. That how do we enable people to have even a high-level understanding of how these systems are working behind the scenes so that they can be more critical in their interactions with these systems, engage in more informed decision-making about appropriate use cases, and also more effectively sort of leverage these technologies to achieve their goals. So back in 2020, in the depths of the pandemic, I was doing some work on how to foster AI literacy through the design of at-home activity boxes for families to engage in within the safety and comfort of their homes to learn about key AI concepts. And I bring this up today because I want to highlight a few takeaways from this early work that have guided sort of my research agenda that I'll be talking more about in the rest of my talk. First, we found that sort of tangible and embodied interaction, collaboration, and creative personally relevant activities were really effective at engaging learners with AI and sort of lowered that barrier to entry. We also found that we didn't need to teach programming in order to facilitate this sort of high-level understanding of AI that led learners to ask sort of deeper questions about the systems they're interacting with. We also found that this process of sort of iterative building and testing of a system led to more learning. So learners that iterated more on the AI that they created and tested it out and then went back and tried it again, they actually demonstrated more learning than learners who just sort of walked through the process once. And finally, another finding from this work was that, and this was kind of a preliminary finding that I wanted to explore more, but we had this kind of preliminary finding that interactive interfaces that allowed learners to experiment with AI models were more successful at facilitating sort of interpretability than visualizations or after-the-fact explanations. So those were kind of the findings that have motivated some of the work that I'll be talking more about today. And I'm going to talk about sort of three sets of artifacts or systems that we've been working on, mostly in informal learning spaces. So the first is a set of embodied creative museum exhibits that we've been developing in collaboration with researchers at Georgia Tech and the Griffin Museum of Science and Industry in downtown Chicago. The second is a set of unplugged activities that we have been developing to engage learners in sort of hands-on experimentation with AI concepts before they even get to a computer. And finally, I will talk about a set of interpretable interfaces where we've been kind of investigating this technology design perspective on things and thinking about how could we potentially integrate sort of interpretable affordances into AI systems that allow people to sort of learn through interaction as they're engaging with AI. So I'll talk first about the museum exhibits. The goal for this project was that we were investigating how to design museum exhibits that leverage embodied interaction and creativity to foster AI literacy, specifically among middle school age students. And I'll talk about two different exhibits that my lab has been taking the lead on. The first is Data Bytes, which is an exhibit that tries to teach young learners about the steps and processes of supervised machine learning by engaging them in sort of physically constructing a data set to teach a computer how to recognize pizzas and sandwiches. So they actually use these sort of tangible fixings to construct their own examples of pizzas and sandwiches. And there's a camera placed above the table that takes a picture of the data set that they create. And then they are able to test out their algorithm and see how well it does at classifying pizzas versus sandwiches. And so they're able to engage in this process, again, of sort of creative, iterative exploration and testing, where they can investigate things like how creating a pizza with unusual toppings might affect the outcome. The second exhibit that we have been working on is called KnowledgeNet, which focuses on teaching learners about knowledge representations and how computers use them to reason and make decisions. And this exhibit is on a sort of interactive touch table with 4 different stations, so it's intended to be collaborative. And learners can create semantic networks, so sort of concepts and relationships between them, to control the appearance and behavior of an animated character that sort of appears in the center of the table in what maybe some might call a micro world. And they can sort of observe how their character changes and how its behavior changes based on the semantic networks that they and their friends create. So we studied these exhibits on the museum floor at Griffin Museum of Science and Industry back in June of 2024, and we found a few things. I'll just highlight a couple of our takeaways here. The first was that creative activities, like making these sort of customizable pizzas and sandwiches and creating custom characters with individualized features, sparked dialogue, exploration, and prolonged engagement with the exhibits. But we found that we maybe needed to better focus the kids' discussion on an AI. They got really caught up in talking about the pizzas and sandwiches, which was wonderful, but the pepperoni was not connecting back to our AI learning concept. So we were like, how do we refocus these discussions a little more deeply on AI? And also, how do we better motivate these iteration and testing behaviors? We found that learners got really caught up in the sort of creation stage of whether that was building their pizzas and sandwiches or whether that was creating their semantic network, but they didn't engage in as much iteration as we were hoping, where they create and then they test and they go back and they make modifications. And some of that is, the nature of designing things for museums. People interact with exhibits for about 5 minutes if you're lucky, so you're working within some pretty strong time constraints, but we wanted to see if we could do better. And I'll just highlight a few iterative design changes that we are currently in the process of making to these exhibits to try to address some of these concerns. The first is with data bites. We are trying to incorporate AI learning objectives in the dataset preparation phase. So yay, learners were super engaged in creating these pizzas and sandwiches. How can we connect that back to some of our learning goals? So we have incorporated some elements into the system where the AI sort of shares what sort of features it's picking up on as learners are creating their initial dataset. And we also made the testing phase more interactive in order to motivate learners to engage in more of that iterative testing behavior. For the KnowledgeNet exhibit, we've been trying to make a stronger visual and language connection to the AI concepts, and also allow learners to create complex characters that might have unusual or conflicting features to get them to kind of ask those questions about, like, why is this happening? Why did that show up that way? And then encourage more of that curiosity and iterative testing and exploration behavior. I'll talk now about our unplugged activities, which the goal of this project was to sort of design unplugged or low-tech activities which leverage embodied interaction and connections to personal identity to foster AI literacy amongst middle school age students. And we have developed 13 different activities which are publicly available. I put the QR code up there. And if you stop by the poster session, we also brought a lot of them here today, so you can stop by my students' posters and try out some of the activities yourself. They relate to sort of 3 different kind of broader topics. The first is introducing AI. The second is understanding AI representation and reasoning processes. And the third is engaging in discussions around AI ethics and data privacy. I'll just highlight 2 of the activities today. The first explores how to create a sort of tangible simulation of AI reasoning processes. So in this activity, students learn about how convolutional neural networks make sense of images. So CNNs break images down into small pieces and identify patterns like edges in those images. And in our activity, learners are taken on sort of a story-based quest to identify a series of imaginary creatures. You can see an example there called quirkies, using this kernel lens tool, which we built out of wood, but you could easily build out of cardboard or other low-cost materials. And you can basically sort of move this small viewport freely over a large picture, revealing only a portion of the picture directly under the viewport, while the rest of the image remains hidden. And learners have to sort of use a field guide to make notes about what they observe as though they are the AI system in order to identify patterns in the image and identify the creature. The second activity I'll highlight is called Data Brokers, and this one is really focused on engaging learners in sort of a personally relevant exploration of some of these questions around AI and data privacy. So this is a sort of interactive game where learners can sort of work together. They take on the role of kind of like a data broker, and they try to figure out how to target ads at particular user profiles. So they're given kind of these user profiles with search history, and they're given these products that they have to market, and they have to decide how to kind of like allocate funds to market products to different users. And then there's actually an answer key that they can check their work against and see how well they did at marketing products. And the answer key has some surprises in it where maybe your search history doesn't 100% align with your actual identity. And so they're prompted to reflect on sort of different user identities and whether algorithms can sort of truly know us and our preferences. I'll just really quickly go through these for the sake of time. We study these in several different contexts, including a summer camp, as well as a study with families in a museum context. We found that the activities supported learning about some of our key AI concepts. And some of our teacher feedback from the summer camp indicated that the kids were more focused on the AI concepts during the unplugged activities than some of the plugged activities, although they complemented each other well. And teachers found certain activities to be particularly useful at filling gaps in the schedule with relevant content, which affirmed one of our original goals, which was to develop easy-to-use kind of grab-and-go activities that could be used by parents, after-school group leaders, teachers, and easily slotted into existing curricula. But we had some questions about how do we improve knowledge transfer to new contexts, and also how do we ensure that we're still accurately conveying how AI works, even when we're sort of simplifying the algorithm a little bit for these tangible simulations. I will close by briefly mentioning our sort of third set of artifacts, which is focused on designing interpretable interfaces. So the goal of this project was to design interactive web-based interfaces to make AI concepts interpretable in the moment, so connecting back to the theme through the day of learning by doing. And we were focused on an adult audience here. So we worked with adults in local libraries, and we're exploring with them how to sort of create these interpretable systems. And we designed a set of interpretable interfaces where basically learners could interact with different AI algorithms and use these sort of interactive toggles to explore concepts like what a confidence threshold is, or how edge detection works, or the role of sensitivity in machine learning. And they could sort of manipulate these toggles and in real time see how that affected how well the algorithm was recognizing or detecting certain things. And some of our takeaways from this project, this confirmed our preliminary finding that these interfaces that facilitate interactive exploration can facilitate learning about AI in the moment. We found that adult learners have varying approaches and goals related to learning about AI. And so we think there are opportunities to leverage sort of adults' professional experience and prior knowledge for AI education for adults. So to sum up, we've sort of designed a ecosystem of AI literacy resources. These are just a smattering that I've talked about today, but I'd be happy to talk about some other projects that we're working on. And we've also identified some of these connecting principles. So embodied simulations of AI reasoning processes concretize abstract concepts. Making connections to identity can facilitate personally relevant reflections on AI. Interpretable interfaces facilitate learning through interaction, not explanation. Familiar, tangible interactions can reduce intimidation surrounding these technologies. And finally, creative tasks allow learners to take on the role of a data scientist. Thank you, and happy to chat more after the session.
Thank you, Duri. Our next speaker is Jaemarie Soylyst. I'll wait till you get up there. Jaemarie Soylyst is a postdoctoral fellow at the University of Washington in the School of Computer Science and Engineering and the Center for Learning, Computing, and Imagination. She recently received her PhD from Carnegie Mellon University in the Human-Computer Interaction Institute. Her research is at the intersection of responsible AI, human-computer interaction, and computing education.
Sorry. Hi, everyone. I'm super excited to be talking about scaffolding critical AI literacy with youth. And throughout my work, I've been really interested in positioning young people as technosocial change agents through different learning experiences. Hopefully this will work. Wow. Okay. All right. So yeah, in this case, I mean youth with agency who can have a role in changing dominant narratives in an increasingly tech-driven world. And so there's both kind of like a knowing and doing aspect to technosocial change agency. Of course, I'm having technical issues. SOS. Okay. For context. Okay. I primarily work with youth in middle and high school in the US, where I run workshop studies, often in collaboration with community partners. And so I'll be sharing some work done with my teams when I was at Carnegie Mellon University. I am fresh out of the PhD factory, so I'm reflecting on some of that work here. So today, AI-driven technology is ubiquitous with many children, as we've covered in prior sessions. Okay. But as we've seen, AI can cause harm in a lot of different ways that we've also covered. For specifics, I do focus on algorithmic bias as one way of harm that I aim to address in my work. Uh, Also, my computer is going dark. Okay. So yeah, since children are regular users of AI, they also face harms. For example, one kind of news headliner was when the UK deployed an algorithm to predict A-level grades for students, which had bias that unfortunately harmed those from lower resource backgrounds in their trajectories to universities. And many teen users are also regularly exposed to racism and gender injustice embedded in and facilitated by AI-driven technologies. And so harm is even more so for youth from systemically marginalized backgrounds. In short, youth are stakeholders, and fair AI is a youth-facing matter. However, they often don't have much control or agency over the AI that impacts them, and so they're not recognized as important contributors to the design and kind of ongoing evaluation of AI throughout its life cycle. And so critical AI literacy can really help youth make informed decisions as they use or even reject AI systems, if they're able to, as well as have agency as stakeholders to potentially participate in kind of broader conversations. And so in prior studies, I've seen that youth possess kind of foundational skills and knowledge that can be further built on and bridged to engage with critical socio-technical aspects of AI, even with some instances of overtrust or overestimation about AI's capabilities, especially now with LLMs. And they are often passionate about and even want to be included in critical discourse, decision making, and design for AI systems that impact them and their communities. And they can especially engage in critical thinking and discourse when they're scaffolded in the right ways that support certain pitfalls like overtrust. Specifically, I've been investigating this idea of critical consciousness as being really core to critical AI literacy. And what I mean by critical consciousness is it refers to the ability to both kind of critique systems of oppression, such as those embedded in and amplified by AI, as well as take action against oppressive systems. And I've been really curious about how to foster youth's critical consciousness in the age of AI. And so this work really helps characterize how critical AI literacy enables youth to take action, exploring participatory, responsible AI, as well as how engagement could cyclically enhance kind of critical AI literacy. Learning by doing. And so I'll share kind of two project strands related to these aspects of critical consciousness that start from the AI literacy and start from the participation in responsible AI. And so in terms of critical AI literacy, for one project, my team and I created the RAD framework, which explicitly supports socio-technical critique of AI in 3 steps: recognize, analyze, and deliberate. But what exactly is critique of AI? Let's step back. The way we've been thinking about it, we've taken theory from critical consciousness, culturally responsive computing, as well as critical literacy. All of these kind of have not just that thinking component, but this recommendation for better technologies. So taken together, critique of AI can be thought of as a socio-technical analysis with recommendations for a more just future. In practice, critiquing AI effectively can be really complex, which requires scaffolding, and this is what the RAD framework is meant to do. So the first step, recognize, refers to awareness of potential AI harms. Youth can sometimes not realize its potential harms, but when they're prompted the right way, youth can be capable of recognizing and then describing problematic AI behavior, sometimes in really great detail. And so recognize is really about being sensitive to AI harms. Analyze refers to considering socio-technical aspects of AI harms, such as who the AI impacts negatively and how. And so this step is meant to support deconstruction of power dynamics and stakeholders of AI in a broader context. And then deliberate is about considering how AI may be more responsible, giving recommendation for future improvement, while analyze is about deconstructing the current AI issue at hand. Deliberate is really about kind of looking ahead to consider outcomes and processes for a more ethical future. To investigate the framework's effectiveness, we ran a workshop study with youth in middle school. We gave youth a scenario to apply the RAD framework about bias in generative AI, given its increasing prominence. And so in this scenario, Jada is creating a presentation for school to share career paths that she's excited about. One of her dreams is to be a CEO running a big company when she uses a generative AI tool, PictureMake, to create images of a successful CEO of a large company. Here are the images that result, which show primarily white men in suits. And this is a real output to that input. I'll next step through the instantiated framework and share associated findings along the way. For recognize, in other words, increasing awareness and sensitivity to AI harms, we started to ask the youth to write sticky notes on anything they saw that was unfair in the scenario, and we also gave a few examples in an unrelated scenario. And so ideas of bias that came up included not even one black person and mostly old guys. For analyze, referring to critically considering socio-technical aspects of AI harms, such as why AI harms exist and how they impact people, we first focused on stakeholders. When we first asked what the term stakeholder meant, youth weren't so sure about this terminology, but they understood the concept and then could even apply it with a definition that we gave. And then they were able to generate some examples of stakeholders given the Jada scenario. And to scaffold, we also added a few extra stakeholders that they could focus on for the rest of the exercise, including school, students, PictureMake developers, parents, and the government for really kind of that scale and scope. And then we asked about the term power. Youth were actually really familiar with this concept, and they were quick to define it as control, which aligned with the definition that we gave them. And they could consider which stakeholders had more or less power in the Jada scenario as well. For deliberate, we had a series of prompts for the youth to contemplate the aspects of AI together and also consider ways of shifting power. We probed, should the AI be used at all? Then, what would be a fair outcome for the AI? Most of their answers really related to this idea of diversity. And then we asked how stakeholders may collaborate, getting at this idea of collaboration, which was inspired by data feminism. Ideas that came up included approaches for co-design, like developers meeting with students and stakeholder feedback processes. And when we asked the opposite, how individuals or communities could take action on their own toward a more fair outcome, if possible, ideas that came up included rejecting the AI by not using it or banning it, breaking the AI by hacking it, using it in ways that can contribute new data and thus more desired behavior. And this idea came from youth who knew about training data coming into the study, so that prior knowledge also kind of enriched their ability to ideate. And they also suggested ways of raising awareness with their communities, as well as collective action, such as protest. If a bunch of people get together, people high up have to do something because they're losing money. And lastly, we probed learners to consider how policy could play a role, tying back to the government stakeholder we had provided initially. Their ideated policies included companies meeting specific standards before deploying technologies, and they also thought of requiring that users and stakeholders be involved so that their feedback is meaningfully incorporated. But if companies didn't comply, the youth also ideated punishments for when they were not accountable, such as monetary fines. Ultimately, through scaffolding through a fairly straightforward framework like this, youth can engage in pretty complex, critical, responsible AI discourse even when they don't have that prior experience about computing, and they can also have insights that could support real-world efforts like forming policies. I could imagine a future where they can advocate for different things for their communities. And so this critique step is really a precursor to potentially exercising further action and participation in responsible AI efforts. Ultimately, critical consciousness is both critique of and action against oppressive systems, but how can youth actually engage in enacting change? And how might doing so enhance their development of critical AI literacy? I look to responsible AI as a field for some inspiration. I'll next cover work on youth's participation in responsible AI processes as an exploratory way of exercising change agency and further developing critical AI literacy. So first, just to more kind of clearly define this term, participatory responsible AI refers to end users and other stakeholders engaging in the design and ongoing evaluation of AI systems toward more just technologies. And by user AI auditing, which is what I focus on as one approach in this route, refers to users surfacing and mitigating harms, such as by using or prompting the AI, realizing issues with AI behavior, and then raising awareness of potential harms. And for time, I can't go into a ton of detail, but there are various real-world examples of how this approach has actually led to remediation of systems in the wild, such as in Twitter. And so, can and how do youth audit AI? In a workshop study with teens, I asked the youth to break the AI, quote unquote, in other words, audit it. And so they were challenged to prompt the AI to output something that they thought was incorrect, they disagreed with, or thought could have harmful effects on people. And we did ask them to keep the prompts school appropriate in their own laptops, but at tables together. They focused on breaking the AI in 3 different types of AI: text to image, search bar autocomplete, and Google search results. And I chose these kind of given the ubiquity of these AI in both youth and adults' lives. So how did they go about auditing these? Through systematic analysis with my team, we found 6 different inputs that youth use to audit across different systems, and I'll just cover a few given the time. Fact-checking included prompts that tested if the AI might output the right or correct information. Identity-related inputs included those that focused on investigating how AI represented aspects of social identities, including occupational roles, race, gender, and more. And so examples included family or engineer. Generational trends included inputs that related to fast-moving trends in culture that were really popular with youth, such as inputs referencing new TikTok trends or trendy terms like brain rot. And we saw that they also identified 4 different types of problematic behavior from the outputs. For example, misinformation, the youth noted that outputs were either factually incorrect or were a misrepresentation, or harmful bias. The youth noted, for example, if there was a social bias produced, such as the output for computer workers being mostly men. When reasoning about the inputs and outputs, we found that they used various kind of funds of knowledge and peer-to-peer interaction when engaging in auditing to hypothesize what inputs might break the AI, for example. So some youth actually had some serious hobbies and interests with really deep knowledge. For example, one had extensive knowledge about sharks, which she used to audit, and another had extensive knowledge about crocheting. They also used facets of their own identity and information learned in school that they connected, such as misperceptions about different continents in world history. And lastly, there was transactivity in their collaborative learning, meaning they learned from their interactions from one another. They might have seen something that was really interesting or successful from their peer and then added onto it. And although we were discussing serious AI ethics topics, there was a lot of laughter, curiosity, shared surprise, and unprompted discussion through the auditing activities. And importantly, through their exploration of AI systems, we saw from their inputs that they tried out more inputs that focused on the socio-technical issues as time went on, as opposed to the technical. In other words, their perspectives of AI systems through auditing shifted from seeing AI as just technical to socio-technical, system. For example, shifting from just fact-checking, checking a technical limitation of the AI to identity-related inputs to audit the AI. And so this work shows that youth can contribute insights as they reveal limitations of AI systems. Although we as adults have been youth at some point, we have not been youth in the age of AI as it is now. And this is a really unique time in the age of AI. So systems could be better with youth inclusions in their perspectives. For example, they're early adopters of technologies. And engaging in actively evaluating AI itself was an educational activity. So there's really opportunity to leverage some of these emerging practices in the classroom and even find ways to include youth outside of the classroom. And we can even situate these in classes that are not computing focused. For example, English or history courses or even economics classes. And future tools could be designed to support this kind of open-ended learning. My team and I prototyped a tool that supports youth in more systematically exploring and learning about and then raising awareness of problematic AI biases, which has some pretty promising results. And maybe this could even allow youth perspectives to be included in real-world discussions and processes with AI stakeholders. So ultimately, there's opportunity to leverage and support youth in learning to develop their critical consciousness that might empower them to engage in conversations as full-fledged stakeholders. So thank you so much.
Thank you, Jaemarie, and thank you to all the panelists for stimulating and thought-provoking talks. I invite you to come to the microphone and get in line for a question. I'll start it off with one question that I'm particularly curious about. So I came to AI in education through Seymour Papert, who I talked about earlier, and Marvin Minsky, who were advisors of mine when I was in graduate school. And Seymour was very particularly interested in this notion of thinking about thinking. And thinking, and AI was going to help us by enabling us to think better about our own thinking, about being able to explicitly notice the structures that are going on in our thinking and hypothesize how they could be working in our own minds and then how they might be changed in learning. So my question is, has this changed? When we talk about LLMs, for example, we don't have explicit structures. We, in many cases, just have black boxes that do things. So have we lost that goal? Are we seeing that it is still stimulating that kind of thinking about thinking? And if so, how?
I can start. A few thoughts on that. I think when AI first started out, it was very much sort of about simulating the way the brain works. And that's why somebody shared how the first sort of beta neural network sort of came out in the 1940s or 1950s. And if you read, I recently read Fei-Fei Li's book on The Worlds I See, which is all about computer vision and how the massive amounts of data that they collected through ImageNet finally made neural networks sort of come alive. And it was this combination of big data with the neural network architecture that really made the sort of spawned the machine learning boom. So I think when you lift the hood, there are similarities, but in the way that it has sort of now evolved into the transformer architecture and the LLMs, et cetera, there is, I think, and the tokenization that's used in the LLMs. I think John said it best this morning. Writing is, the LLM is basically putting together some syntax. They're not really writing. And I think you're right, it has sort of bifurcated a little bit. I don't think the way LLMs work is in any way the way humans are working. So I think there was earlier in the field, there was, the symbolic logic, the rule-based logic, etc. There was similarities between the way the machine was being trained to do things and the way humans do, but that feels like it has diverged. So that's just a simple answer to one part of your question. I don't know what.
I'll sort of yes and that. I also think that there's still opportunities for sort of like productive conversations about, especially as kids are learning how to sort of like navigate their own identities in the age of AI and figure out sort of what is the value of their thoughts, like we've talked about today, in with respect to these systems that they're using that are kind of presenting themselves as experts or really intelligent. I do think there are productive conversations to have for kids to kind of compare their own perspectives or intelligence or thoughts to AI and think about like what can they sort of like uniquely bring, or what makes them sort of uniquely valuable as people in various different contexts. So yes, and also I think there are some important conversations for kids to have when kind of comparing their own intelligences to the artificial intelligence.
Yeah, I agree. I think, I wonder, what the future looks like to support youth in kind of like questioning AI as well, kind of playing off of the talks that happened and, for example, taking inspiration from different cognitive fields like theory of mind to support or build into technologies that that youth are using.
Okay, I
Feel free to come
Yep,
up on,
that's what I'm doing.
this line. I think
Yeah.
we still have 5 minutes left
Yeah.
for questions.
At the whole start of this, one of the issues I always had with literacy demands in education are to what purpose? I mean, one of the problems with the definition is well, they should understand, but why? And I liked and didn't like the RAD. I liked the react and analyze, and I liked what you described deliberate meant, although I wondered why it was called deliberate. It seemed to me more important was it was react, analyze, and then design, or react, analyze, and do. Because what really turned out was not, oh, let's sit and think about what that means. It was like, we should do the following. Either we should not use it, we should mitigate how we use it in some ways to mitigate the damage that requires. So I just, am I wrong? Isn't really the ultimate thing we should be trying to define and looking at in literacy is how it should change the behavior and looking for particular failures, reduction of mistakes, better use, more effective use. Shouldn't that really be the defining characteristics we should be looking for in literacy?
Oh, yeah. I will say that I did have a couple conundrums about the D in the RAD framework. Maybe it's dream, maybe it's do, maybe it's design. There was maybe an alternate version where it had 2 Ds at the end. So I totally hear you there. To me, I think AI literacy, and I do focus more on kind of like lightweight interventions to support youth in critically navigating their lives and pushing for change if they see a need for it. I also work a lot with systemically marginalized youth who often are not having the best interactions with AI. So I want to kind of like echo a sentiment that I hear you say, which is around the do. My goal for a lot of my work is around how do I support youth in being able to make change.
I'll just speak briefly to that question of like why. I've thought a lot about that, and one of the answers I've come up with for myself at least is that I think unlike other technologies that we're using, AI is making decisions sort of with us and for us. And I think some of the why around AI literacy is to be able to critically interpret those decisions, and also more effectively leverage AI, thinking about what context it's appropriate to use in, what it's not, how do I best, leverage it to accomplish my goals. So I think that decision-making capacity of AI tools and the way that it's being integrated across many facets kind of is some of the why behind it for me of why is this necessary.
And just to add to that, I agree with what Jaemarie and Duri said. Just to add to that, I think it's important to understand what you're using in order to be able to use it well, of course, but also to critique and question its use. That is something that has sort of come up, especially because of the way AI is being sort of spoken about and marketed today to sort of take over jobs or start doing things for us. So I think it's the literacy piece sort of allows you to question and decide and make decisions about when to use it and in what ways. And I think to sort of cut through a lot of the hype and the anthropomorphization and all of that, I think it's only when students sort of understand this technology and understand what it is and what it does and how it does it, that they can really be informed users or designers or any of that.
Thank you. I think we have time for one
Hi.
last question.
Thank you. So thank you for the discussion on AI literacy. I thought it was quite interesting socially as well. One of the questions I have is around what is Gen AI doing? That's an interesting question. And I'm like, oh, Gen AI depends on the transformer architecture, which depends on multi-head attention, which depends on basic neural networks, which depends on gradient descent, which depends on calculus, which depends on also linear algebra a bit, which depends on basic algebra and basic math. And learning scientists have been studying, and education theorists have been studying, how do we get the majority of people in this country or in the world to understand the basic concepts of algebra. And most of that has not succeeded, right? A lot of progress has been made, but basic algebra and calculus is still a challenge. So how do we kind of expect, how do we resolve the social interest, the political interest, and we want to pump a lot of money into AI and AI education to actually understand that transformer architecture, you have to go back down all the way to understanding the algebraic concepts, which most youth don't understand. So I'd like to hear a little bit of discussion on that front as well.
The father of all these disciplines. Interestingly, I've been interviewing a group of women AI trailblazers as part of an ongoing Women of AI project. And one of the last questions I asked them after asking them about their work and their trajectory and their journey is, what message do they have for young learners who might be hearing their stories and seeing all this AI development around them, and what advice might they have about maybe entering the world of AI as a career or whatever? What message do they have? And interestingly, a lot of them have this message about, don't be afraid of math, go ahead and do math. A lot of it is math. After all, these are AI researchers and scientists. So they are, not necessarily just users of AI, but they're very much creators of these new algorithms and AI models and things like that. And so they do say, that math is at the core of all of this, and so, go ahead and do that. I think one other comment that I have is that the consensus study that I mentioned, the National Academies, we were very intentional in talking about competencies for not a future of AI, but it's a future of data and computing. And we feel that those are foundational. Of course, you can keep going down and saying that there's something more foundational for understanding computing as well. I think it's important to keep an eye on, not lose sight, rather, of what these foundational competencies are. I think there is a lot of incentive to sort of start teaching these new things, these new technologies, without really sort of it's a zero-sum game at the school level. The time that you take into teaching about AI or this or that is time taken away from some other important foundational learnings. So I'm all for still teaching math well, and perhaps there are ways in which we can maybe integrate AI to help with that. People talk about, we're now going into the realm of AI in education. I think there have been a lot of challenges that, the world at large has faced with teaching some of these things, but the US especially. And I think AI can perhaps play a role in that. So I think my answer was all over the place, but.
I'll maybe just add that I think like a little goes a long way. I think in some of what I talked about in my talk, like even just recognizing that computers learn from data is like something that, and learn from our data, is that something that a lot of people don't necessarily know or recognize in terms of the systems they interact with in their everyday lives. So I think, yes, math is important and math is foundational, but also I think there are some things that can help people interact with AI systems in more informed ways that might involve like sort of a very, very high level understanding of how these systems work and some of the basic ways that they function. Yeah.
Yeah, I just have a little bit to add on to that. I think that ideally, learners would have this more extensive kind of functional knowledge of how AI works, which would include the math aspects. Pragmatically, I think a lot of communities aren't resourced to get every learner understanding those concepts. So I think it's kind of like, I heard the word intuition, I think, earlier, like almost like an intuition about AI is maybe a place to start, a lightweight support, and then if there's opportunity to provide that like functional knowledge or mathematical knowledge that can really enrich. And I mentioned a little finding from one study where that background really does enhance things. So you're so right that that can make things a lot more clear in terms of understanding.
Thank you all so much. Right, let's thank our speakers from this session. And feel free to. All right, I want to just thank you all for a wonderfully engaging day. Uri, can I send you over there to talk to Mike for a second, please? Thank you. So in just a few minutes, we're going to be able to continue the conversation over drinks and food. We have a reception coming up next, which is great. But first, I just want to give one more big round of applause for all of our speakers. This has been an incredibly thought-provoking day, so thank you. And yeah, I've learned so much. I think one of my big takeaways from today that I've heard kind of across a lot of the different talks is that we have kind of a real need for more research at the intersection of kind of learning sciences and the design of AI educational tools, and also for work that's kind of working on translating into practice, right, and affecting what's really happening in real kind of learning environments. And so I want to highlight kind of two different things in this space. So first of all, we mentioned at the beginning our kind of joint PhD program in computer science and learning sciences that's trying to train people kind of in thinking across really different disciplines. And we talked a little bit about, camps of thinking that are sometimes diametrically opposed to each other. And so I just want to highlight that as one place we're trying to do that. And I would love to talk to others about ways we can kind of expand that type of training to other programs and whatnot. I also want to mention, Sapir wanted me to mention the Spencer Foundation has a new initiative on AI and education. So Sapir Vakil and also Ezekiel Dixon-Roman have both been involved in shaping this, which aims to fund research at this intersection. So if you've been inspired today and are wanting to do work in this space, there is some non-NSF funding that is kind of being launched. So I just wanted to make sure everyone knew about that. I also want to thank all of our poster presenters, thank you, Mike, for sharing their posters. We had a committee of 3 faculty members who went around and visited the posters during the poster session, and we have a student poster award. So I'm thrilled to share that the winner of the student poster award is Aiden Fitzsimmons. Congratulations, Aiden. So you can come up after, we'll take a couple pictures, but I just wanted to let you all know that the posters are going to be open still during the reception. The poster presenters will be here, so make sure you have a chance to visit the ones that you haven't talked to yet, and congrats again to Aiden. All right, so the last thing, and then I promise we'll get out of here, or get to the fun part, I guess I should say. I want to thank all of our sponsors across the university who have made this event possible in a very kind of complex and financially uncertain time. So this includes the Office of the Provost, the McCormick School of Engineering, the School of Education and Social Policy, the Office of Research, and the Cognitive Science Program at Northwestern. So thank you, sponsors. All right, and now we can continue the conversation at the reception. I have just a couple kind of logistical details. So we are gonna have kind of drinks available and food. We're gonna be passing out drink tickets. So as you leave this room, just check in. We'll have some student volunteers standing by the base of the stairs. So make sure you get a couple of drink tickets. This will get you both alcoholic and non-alcoholic drinks. The reception is going to be held out in the kind of poster area, and there's also another room across the hall, so feel free to pop in there as well. And Mike has something else.
Sorry, I do have one very important thing to say, which is that Nell did so much work for this entire thing. She really did the lion's share of organizing and running. We were a committee we supported, but Nell is really the person who made this all happen. So we just wanted to share that. Thank you so much.